Hi, this is part 3. Okay, so now we'll convert from a gradient intercept form into a general form. Here we have the equations, gradient intercept in general form is written like that. So this is in gradient intercept form. I can see the gradient and the y-intercept. First, we'll multiply both sides by 3. And then we'll move the minus 2x to the other side, and we get 2x plus 3y equals 6. So that would be ax plus by plus d written in that form. Or as the might be seen in the test, ax plus by plus d equals 0. So in this case, it would be 2x plus 3y minus 6 equals 0. And so maybe the example for any question would be solve everything and give your answer in this general form or this general form. Okay, taking the general form and converting into the gradient intercept form. So in this case, we want to isolate the y eventually. See? So moving the 3x to the other side, dividing it by the coefficient of y minus 4. And we get y equals 3/4 x plus half. Here I can see the gradient right away and the y-intercept. Let's do an example. So in this case, write in general form, that would be y minus 2 over 9x plus 8 over 9. I'm multiplying by 9 on both sides. I get 9y. Let's just 9y equals minus 2x plus 8. And adding 2x to both sides, I get 2x plus 9y equals 8. Writing gradient intercept form. So let's solve this one right here. So that would be, I want to isolate the y, so I'll move the 3x to the other side by subtracting both sides. By 3x, I get minus 3x minus 4, dividing by minus 13 both sides. Then I get y equals minus 3 over minus 13x minus 4 over minus 13. That is y equals 3 over 13x plus 4 over 13, because the minus and the minus are positive and minus is positive. Again, stop the video and solve some questions from the previous slide. Match pairs of lines of which are part. Let's explain why a gradient of the line with general form is minus a over b. So gradient, we're looking at the gradient intercept, so we want to isolate the y. By equals minus ax plus d. Dividing both sides by b, I get y equals minus a over bx plus d over b. So we can see straight away that the gradient is minus a over b. Match pairs of lines which are parallel, so reminding you that for parallel lines, their gradient is equal, and for perpendicular lines, m2 equals minus 1 over m1. So let's see, here I can see that it's, okay, that is the gradient intercept form, and this is the general form. So y equals minus x plus 4. I can see a and d both have the same gradient, meaning they are parallel. You can check for the other two as well. For the gradient, for the perpendicular, let's see. First, we want to isolate the y. So in this case, it will be 2y minus x plus 1. Y equals minus half x plus half. So I see here straight away that this might be a good perpendicular. Let's see why. Okay, M2. This is the formula for perpendicular line, but it was also stated that it has to be negative reciprocals. So the negative reciprocal of -1/2 would be 2, because the negative, they change in sign from negative to positive, and 2/1, you see the denominator and numerator have switched places. That is the reciprocal, which equals 2. So A, and also here I see straight away the gradient is 2, so makes them perpendicular lines. You can check for the other two as well. Okay, finding in general form the equation of line, which has, so let's practice what we saw in previous videos. I'll use the gradient intercept form to find the equation of a line, because I think once we understand that, we know how to move to the general form as we've seen before. So this is a reminder, that's the y, that is x, and that is the gradient m. So 2 equals -4 times 1 plus c. 2 equals -4 plus c. 6 equals c by adding both sides 4. So now I have the equation in gradient intercept form. Y equals -4x plus 6. If you want to change it into the general form, then that would be 4x plus y equals 6, where I have the x and the y on one side and the number on the other side according to this instruction here. If we have 2 points, how can we find the equation of a line? So once we have 2 points, we find the gradient. Once we have a gradient and a point, we know how to find an equation of a line. We just saw that. Let's solve this. So first I need to find the gradient, would be if this is x1, y1, x2, y2. So the formula for gradient is y2 minus y1, x2 minus x1. That would be 5 minus 2 over 4 minus 7, that is 3 over minus 3 equals -1. So now I have a gradient and a point. Either one would be good, and we just saw how to find an equation of a line with gradient and a point. You can continue and check your final solutions. Find in general form the equation of a line. So we have 2 points. We can find the gradient once we have 2 points, and then with either of the points, one of them, and the gradient, we can find the equation of a line. Same for all those. Find in gradient intercept form the equation of line 2. So here there's a trick. We see it's parallel, but it's not enough. I see this sign, this notation here, meaning those 2 lines are parallel. Using this arrow means they are parallel. So we have to see that. Okay, so if those lines are parallel and I have this point here, and that means if the lines are parallel, that means they both have the same gradient. And the gradient is found here, 3/4. So now I have a point and a gradient. I can find the equation of line 2. Once I have, let's find it and solve B. Y equals mx plus c. So I have a point, it's 3, 1. So it's 1, the y is 1. M is 3/4. X is 3. Now I need to find c. So that is 1 equals 9 over 4 plus c. I can see, you can use your calculator. C equals 1 minus 9 over 4, which is minus 5 over 4. So now y equals, the gradient is 3/4 x minus 5 over 4. Find the y-intercept. So now it's really fast. and easy to find the y-intercept because it's in gradient-intercept form, and the c is the y-intercept. So the answer for that would be -5/4. Find the equation of line which is parallel and passes that. So we just saw that. This is parallel, so they have the same gradient. So now I have a point and a gradient, which is 3. Or in this case here, I want to write it in gradient-intercept form, so I'll move the y to the other side. That is 2x equals y minus 3, and I'm going to add 3 to both sides. Y equals 2x plus 3 by moving that to this side, and then I'm just changing the order of 2x plus 3 equals y to y equals 2x plus 3. And now I can find easily that the gradient is 2 and I have a point. Great. Perpendicular, so if a -2, so the perpendicular of -2, I'll write it as a -2/1. That would be half. They change in the sign and there are reciprocals. So now I have a point and a gradient. So here you need to find, first change it into gradient-intercept form and then find the gradient and you have a point. And determine whether a point lies on the equation. So to see if the point lies in the equation, all we need to do is substitute 11 for y and 3 for x. So is 11 equals 4 times 3 minus 1? 12 minus 1, yes, 11 equals 11. So the point 311 lies on the line here. You can do the same with the rest. Find m. Okay, now we have some kind of an unknown that we're going to work with. Find c given that this point lies on the line. So if this point lies on the line, I can substitute 15 for y and 2 for x. And then just find what c is. In this case, it's 7. Find t given that t, 4, lies on the line with the equation. So t would be the x. So, and y would be 4. So 4 equals 2/3 t minus 4/3. And we need to find what t is by multiplying 3 both sides. We get 12 equals 2t minus 4, and you can continue from here to find what t is. Find k given that this lies on the line, doing the same, substituting for the x and y and finding k. Find the equation of line 2, write your answer in the form. So this is great. This looks like an IB question that you have finding the math showing, but you give your answer in the certain according to the instruction. So if we need to find line 2 and we have line 1, I see in line 1 I have 2 points, so I already can find the gradient of line 1 from 2 points. And because they are perpendicular, I can find also the gradient of line 2, that is -1 over m1, or just doing the negative reciprocal. And now I have a point, 2, 4, and gradient 2, and working with this formula here, we can find the equation of this line 2. But then we need to give our answer in the form of ax plus by plus d equals 0. Once we have that, okay, I don't know if we have time to solve everything. Once we have that, we can find the x-intercept by just substituting y for 0. Okay, in this case here, the y is 0, so we can find what is x. Here you have the final solutions. Thank you for listening and good luck. Solve and see that it works for you.